So a couple more problems, practice problems from lesson 4.3. Starting at the left, 15 times 3 to the 2x equals 90. And the first thing that we're going to do is we're going to divide both sides by 15. So we're left with 3 to the 2x equals 90 divided by 15, which is 6. And ultimately what we're going to be doing is we're going to be trying to figure out what is an exponent value. So in order to be able to do that, what we're going to do is we're going to put a logarithm in on both sides. So it's going to be log of 3 to the 2x equals log of 6. And the reason that we do that is because we want to use the logarithmic property, which says that we can take the 2x and we can write it out in front. And that gets the variable out of the exponent position so that we can solve. So it's going to be 2x times log of 3 equals log of 6. And what's going to happen is we're going to divide both sides by log of 3. And now we're left with 2x equals, and let's type that into the calculator. You can use Desmos if you prefer, but I'm going to type in log of 6, close the parentheses, divided by log of 3. And that gives us this decimal. Don't clear it out of your calculator. Leave that number in there. I'm just going to write 1.6309. But as we finish here, you see it's 2 times x. We're going to divide both sides by 2. So again, going back to the calculator, we divide by 2. The number that was already in our calculator, and we get 0.815 for our answer on that particular problem. Very similar with the problem to the right. We're going to be solving for an exponent, which means we're going to have to use a logarithm. But the difference on this problem compared to the previous problem is that there's an e in it. But we still start by dividing both sides by 7. And we get e to the 6x equals 6, 42 divided by 7. And now again, the variable that we're solving for is an exponent, so we're going to put a logarithm in. I'm going to recommend, because it's an e, that you use ln, the natural logarithm. However, it does not matter. You don't have to. But once we get this, we're going to do the same process. We're going to figure out, using the properties, how to get the 6x out of the exponential position. And we're going to do that with our property. So it's going to be 6x times the natural log of e equals the natural log of 6. And there's a nice little feature, and in fact, sometimes, I think it may have been in section 4.2, it asked this question. The question is, what does the natural log of e equal? And the natural log button is on the left side of your calculator, or it's in the functions miscellaneous section of Desmos. But I'm going to use the calculator here. So natural log, that button, and then the E button. Before I show you on my screen, I'm going to type in second in the division bar. So second division bar gets an E. And when we type in the natural log of E, look what happens. We get 1. So now that we have that, this is 6x times 1 equals natural log of 6. I do not want to skip that step. I know some of you are saying, why do we have to write that? But I don't want to skip that step. 6x times 1 is 6x equals natural log of 6. And we do ultimately want to figure out, well, what does x equal? And now that we've got that, we can take the natural log of 6, close the parentheses, divided by 6. And what we get is we get that x equals 0.299.